All right, this lesson is Trig Identities. This is my personal favorite lesson of the whole course, so I've been looking forward to it all year. I hope you enjoy it a little bit. Now, what is a trig identity? A trig identity is an equation that is true for all values of the variable given. An example of one of these equations, sine x times cosine x times tangent x is equal to 1 minus cosine squared x. So this is always going to be true that the left side is equal to the right side for any value of x. Now you have to put in the same value of x. So if you put in any x value, any one x value into all those places for x, the equation will work. Same thing with this below, sine x divided by cosine x is equal to tangent x is always true. Now it's not enough to just substitute in a value for x and see if the equation works. We have to prove it for all values of x. There are two main trig identities that I'm going to derive for you right now, and those two will help us solve the other identities later on. The first one is called the quotient identity. So it's actually one of the ones I just showed you, that tangent x is equal to sine x over cosine x. So I'm going to prove to you that this is always true, and then we're going to be able to use it later on. Now, when we solve trig identities, we're going to be splitting up our solution into two parts, the left side and the right side. We don't work with both sides at the same time, we work with them separately. So the left side is simply tangent x. So what I'm going to do, because we haven't learned any identities yet, I'm going to be looking at this triangle that I've put together down here. We've talked in previous lessons about how we're using y, x, and r now for our sides of a triangle. So if I take a closer look at this triangle, remember that our related angle is this one right here. So what would tangent x be for that triangle? It would be y over x. So what I'm going to try to prove now is that sine x over cosine x will give me the exact same result. So let's take a look. So I'm going to, let's just separate this a little bit. So my right side is sine x divided by cosine x. Looking at that triangle again, sine x for that triangle would be y over r. That's opposite over hypotenuse. That will be divided by cosine x, which is x divided by r. So I've written a division sign instead of a fraction, just so it's a little more clear. So we know by now how to divide a fraction. We multiply by the reciprocal, so multiply by r over x. Now you may be able to see what happens here. Those r's will divide out. And what we're left with is y over x, which is the exact same thing that we have on the left-hand side. So now what we can say is, since left side equals right side, therefore tangent x is equal to sine x over cosine x. This is now an identity that we can use whenever we want for any other trig identity question, because we know that it is always true. The other identity that we're going to use is called the Pythagorean identity, which is sine squared x plus cosine squared x is equal to 1. So again, I'm going to prove to you that this will always work, and not really spacing this out well, but that's okay. So the right-hand side, it doesn't matter if we start with the right or the left, the right side is just 1. So we're obviously not going to be able to do a whole lot there. But let's work instead with the left-hand side, which is sine squared x. We talked about this in a previous lesson. That means sine x is squared plus cosine squared x. So we have to prove that this is always equal to 1. Sorry about my penmanship. I've ordered new pen parts. Anyways, looking again at that triangle, what is sine? Well, sine is y over r, but that will have to be squared. Plus cosine squared x is x over r, and that is squared. Now, if I expand this a little bit, I'll get y squared over r squared. Sorry about my pen. It's kind of annoying. So y squared over r squared plus x squared over r squared. So now I want to actually add those together. Now, luckily they have the same denominator, But here's my thing. So if I add the numerator, I have y squared plus x squared. Well, remember in a triangle, one side squared plus the other side squared gives you the hypotenuse squared. So this is why this is called the Pythagorean identity, because by using the Pythagorean theorem, this will now give us r squared in the numerator, that's x squared plus y squared, over r squared, which is 1. So the left side does in fact equal the right side. So since left side equals right side, therefore, for any value of x, sine squared x plus cosine squared x equals 1. So this right here is another identity that we can use for future questions because we know that this is always true. So you're going to have to commit these two identities here and here to memory. So now I'll show you what an actual question looks like. And when we do these questions, here are some hints that we're going to use. So first of all, like I said, we work with only one side of the equation at a time, left side and right side. And we're going to be substituting in those two identities that we just learned in order to make those two sides stay the same. So here are my hints. Number one, if you see tangent, substitute in the quotient identity. That's sine x over cosine x. Most of these questions, we don't want to be dealing with tangent, as you'll see later on. So the quotient identity, always put that in the place of tangent. Now, if you have sine and cosine in the problem, and at least one of them is squared, use the Pythagorean identity so you have only one type of ratio. So for example, if on the left you have sine and cosine, but on the other side you have just sine, well, that tells you that you don't really want that cosine on the left anymore. So try to put things in terms of just sine or just cosine. And my number one thing is, if you substitute something in or something out, don't put it back in. You don't want to undo the work that you did. One more thing before I go on. One thing we can do with the Pythagorean identity, and really the quotient identity as well, but not as much, we can rearrange it. So for example, if I wanted to isolate sine squared x, what would that give me? It'd be 1 minus cosine squared x. It can also go cosine squared x equals 1 minus sine squared x, whatever way we want. So I'll do this first example and I'll do the others in class. So I want to prove that cosine x times tangent x is equal to sine x. So my left-hand side, I have cosine x times tangent x. So I want to simplify this a little bit, and I want it to match the right-hand side eventually, which is sine x. So looking at that right-hand side, well, I don't really want either cosine or tangent. I want to get rid of both of those somehow. Well, remembering the two identities we just saw, there's something I can put in the place of tangent. So what we'll have here is cosine x, but then times, instead of tangent x, sine x over cosine x. Now I can simplify. Now that I've substituted that in, I can simplify as much as I can. Well, I'm going to get cosine x times sine x divided by cosine x. Those cosine x's, they divide out, and all I'm left with is sine x. Well, that's exactly what my right-hand side is. So that means I'm done. They match. So we're always going to have a statement here. So since the left side is equal to right side, therefore cosine x times tangent x equals sine x. Now, this is one of the easier trig identities that we'll have. It only involved one substitution and then one more step for simplifying after that. But some of our trig identities might involve both of the identities that we learned. It might involve factoring or expanding or a whole bunch of things. So we'll go through the rest of these examples tomorrow in class, but make sure you understand what I had here in the video.